Okay, this is the very first full node benchmark test. This video is going to capture the test as it unfolds. This first test, first of all, I should start. This is a recording of these benchmark tests, which are defined here on GitHub. It's currently under my personal repository, Chris Troutner, and then in the benchmark-BCH repository. This is the cache stack. This is what we're testing today. For the full node, I am using ABC version 0.20.0, which is a little old, but it's functioning okay. And Blockbook version 0.3.1 is what I'm using for the indexer. BCH API is what I'm using for the REST API, but it's basically it's a fork of rest.bitcoin.com, so it's essentially the same thing. And then this is a diagram of the system, so ignore this SLPDB block. This is not going to be involved in the test today. This full node test. If you scroll down, you can see the different types of tests. We're going to be running this node test, which all the tests test the system as a whole, but each variation of the test focuses on a particular subcomponent, and this test is going to be the node test, which focuses on the full node's ability to receive and send transactions rapidly in a real-life mainnet situation. So this full node is what I'm going to be stressing. I've got it set up like this. I've got a REST API. This is all using DigitalOcean droplets with 2 gigabytes of RAM. In fact, I've got the stats here. I have one droplet running a wallet app, which is going to actually run the test, and that's one CPU, 2 gigabytes of memory. The REST API is running on another droplet, which is just one CPU, 2 gigabytes of memory. The full node is running on a droplet with 2 CPUs and 4 gigabytes of memory. And then it also has this external volume, which is what holds the blockchain. And then the Blockbook indexer has 4 CPUs and 8 gigabytes of memory. So the test that I'm going to run right now will send one transaction per second. And this is I'm not going to have any issue running this test in terms of throughput. The intention of this test right now is to establish a baseline and basically a reference, and then from here I will step it up. The next test I'm going to run will be 10 transactions per second, and we'll see how that performs relative to this test. So in this full node test, it does one transaction per second, and one transaction translates in this test to 4 requests to the REST API. So the flow for one transaction in this test looks like this. The wallet app gets the balance of a Bitcoin Cash address, and these what sets this test aside from other tests like the indexer test is all of the UTXOs that are going to be spent in this test have already been staged and confirmed, and so the indexer doesn't really need to do much other than just report its current state of the database. And that's what makes this test more of an emphasis on the full node. So the flow is it checks the balance of the address, it gets the UTXOs for that address, it validates the UTXO with the full node because the UTXO data is coming from the indexer, so it's always important to validate a UTXO with a full node, since that's more of the source of truth, before you spend it or try to spend it. And then finally it'll broadcast the transaction. And so this chain of events is what it's going to be doing once per second. And okay, so I've got the different droplets staged. Here is, I'm just going to refresh all these windows. Here's the droplet running the REST API. I just ran a wallet. You can see a little bit of a blip on the CPU usage here and a spike in the bandwidth from when it was working and talking. So I'm expecting similar results here. I'm not really expecting much to see as a result of this particular test. When we step up the throughput, it'll be different. This is the full node. Again, you can see very little activity. The CPU load came up a little bit with the last test, but it's pretty pretty lazy, not stressing it at all. I'm not expecting to see like again, this is a baseline, so I'm not expecting this to really stress anything. And then Blockbook also, we can see these spikes in traffic, but there's not really much going on. Let me show you the consoles that we'll be monitoring. This is the output of the REST API, and so you can see these different API calls that I made in a previous test before I started the video. This is glances. It keeps an eye on the state of the computer. So right now it's basically idling. CPU usage is at less than 4%. Memory is at about 25%. This is for the REST API, and then I've got these other series. So this is the full node. Right now I'm monitoring the debug log, so you can see that it's fully synced, and these can be ignored. These are from SLPDB. So right now it's just there. It's staying synced to the network. It's doing its normal network activity, which is it's sitting at about 12% CPU and about 40% memory usage. You can see Bitcoin D here specifically is using about 12% and 25% of the memory, just sitting at idle. And then finally there's Blockbook. This is the running log of Blockbook, and it's just sitting there staying synced. It's basically in idle mode right now. It is using about 50% of its memory, so it's an 8 gigabyte droplet, so that's about 4 gigabytes of memory just sitting there. And yeah, okay, so this is what we're going to be monitoring as the test goes on. So let's run the test. If I go back to the wallet, I have these staged wallets, and I've already updated them. Oh, and then finally, just to go back to the directions here, I've got all these settings set, and I have recorded the daily transactions for the last 7 days on the Bitcoin Cash network, because this is a factor that will skew the current network activity. So the average over the last 7 days is 52,000 transactions per day is the average transaction volume on the Bitcoin Cash mainnet network, which is what we're running this test on right now. Okay, so I'm going to run this test. Run full node test. I think it's run node test, and I'm going to use this wallet right here that I've staged. Okay, so we're starting the test at 9:07 a.m. is probably when it's actually going to start. So this has 300 UTXOs, each in its own unique address, staged, and it's going to spend one UTXO per second. So it's 300, so that's 300 seconds are in 5 minutes. So this test is going to run for 5 minutes. And while it's running, we'll be able to look at the glances and the logs, and just make sure everything's working properly, and see how it stresses the system. So right now it's calculating the addresses, and then it will enter a loop where it spends 1 UTXO per second. So 9:07, pretty much. I think we started that right at the top of the minute. Okay, so there's the addresses we're going to spend, and there it goes. It's off and running, spending the UTXOs. So if we look at the REST API, we can see the API calls coming in. If we look at glances for that machine, we can see it's not very stressed out at all. This is just a 1 CPU machine, so it's single-threaded because Node.js application. So the REST API is only using about 7% CPU and 25% of its memory. There's nothing coming in the debug logs because the full node doesn't. We're looking at the full node now. That doesn't really. I don't have it set up to talk about the transactions it's seen in broadcasting. If we look at glances, we can see that it's bumped up, to around 5%. So not really a significant increase in resource usage by the full node. It's doing really well. Blockbook is also doing really well. It's using almost no CPU. It's using 50%. Okay, we can still see that coming through. We can still see those coming through. I'm a little worried about Blockbook. I should be seeing more of an output here, but there's probably a reason for that. But because this test runs over a 5-minute period, we'll be able to look at the end of it. I'll refresh these pages and we'll be able to see it reflected in this 6-hour, which is the minimum that DigitalOcean provides. I could use something like NetData to get a better, more refined view, but again, I'm not really. This system is not being stressed right now. It can handle 1 transaction per second continuously, and it's not under any amount of stress. Okay, there we go. So the logs are coming through. There's just big delays, probably because the system is actively working on servicing API requests. This is Blockbook. Normally, I'm used to seeing like a steady stream of updates just like this, but I think they're delayed now because it's spending more time, and I have Blockbook running as a single-threaded application. You can run this in multi-threaded mode. I just run it in single-threaded mode because it's safer and more predictable that way. In multi-threaded mode, there's a chance that it could corrupt its database, so that's why I choose to run it in single-threaded mode. In production, this would probably be run in a multi-threaded mode. But yeah, you can see it's getting the address, getting the UTXO, which are the 2 calls over and over and over again that it's making. But this is live. You can see the numbers changing. So it's we're a couple minutes into this now, and Blockbook is not being stressed. This is the full node. It is also not being stressed. We see CPUs pushed up to 15%, and that's Bitcoin D. So it is doing something. Memory usage has not increased significantly. I think it was at 5% when we started, and so now it's hovering between 10 and 15%. So this is a 2-core CPU or a two CPU VPS droplet. So and I believe that it's multi-threaded. So a Bitcoin D is. And again, REST not stressed at all. Yeah, this is still going on. This is a 1-core machine running Node.js JavaScript, and we could easily be running 10 instances of this on the 1 core, if we were trying to maximize CPU usage. So everything's pretty lightweight, like I expected. We're not at the end there. If there are any errors that we missed while I was looking at the other screens, it'll pop up at the end and show an error count. I'm not expecting there to be any. So these are all live transactions. If I go to the Block Explorer, you can look and see it's broadcasted because it was just broadcasted. It hasn't been confirmed yet. Spending very small amounts of BCH. So I'll just let this run to completion and keep checking on these glances tabs. This is pretty much what every test is going to be composed of, is just monitoring the systems, seeing how they change, and it's important to record this so that you can go back and look at what they were at the beginning of a test and then in the middle of a test. So again, Blockbook, just none of these systems are being stressed right now. 1 transaction per second just isn't really doing anything to the full node or the REST API or Blockbook. So let's see, it's 9:14. Test should be wrapping up here pretty quickly. So all these 300 transactions are going to appear in the one block, because we have not gotten a block update since we started the test. So yeah, it's still hanging out below 15% for the full node. And memory usage hasn't increased at all. Mostly because, well, I guess there are some UTXO updates with the spending. The mempool would be getting updated, because these are all confirmed UTXOs that are being spent. So they'll be moving out of, or be moved into the mempool, or shifted around in the mempool, I guess. Okay, completed 300 transactions, no errors. So if something had happened in that downstream pipeline from the wallet app, just to go back here. So the wallet app is basically talking directly to REST. That's the one thing that's not in this diagram. And so if there was any, if like the full node or the indexer like had a problem or thrown an error, it would have come back up and we would have seen something here, and we would have gotten, you know, an increase in the error count. So yeah, that's a successful test. And let's look real quickly. Let's refresh these blocks, or these graphs. So again, this is the REST API, and you can see a spike in bandwidth. This is the test I ran before I started the video. This is during the video, but no significant increase in memory usage or CPU. This is the full node. Again, you can see a slight increase in CPU usage. I don't know what these spikes were. You know, pretty heavy bandwidth usage. That's to be expected. It's just doing what it has to do to. This is what the test focused on. So if we saw any significant increase, we would see it right here. So yeah, you can see the stats right there. And again, this is a 4 gigabyte droplet with 2 CPUs. And then looking at Blockbook, we're also not seeing, like, just a tiny rise in memory usage and no significant rise in CPU usage. There is a spike in bandwidth that tells us that the system's actually running and recording. Okay, so this is the very first full node benchmark test right here under the full node. I am going to compile this data and link to the video at the bottom here, and so hopefully as we run additional tests, we'll compile data that can be shared and collaborated upon.